Hello and welcome to section 6.1. In this one we're going to be dealing with slope fields and differential equations. So we're going to start with some just definitions to remind you of what's going on here. So we have the general and particular solutions definition, and this goes back to what we talked about before. A solution of a differential equation is basically if we're given a differential equation which might be something like y double prime plus y equals 0, if I can plug in f of x in for y and then the second derivative and they add together and get a 0, that would be considered a solution to the differential equation. So I have an example down here and I'll try to work through it a little bit. So it's saying we want to show that y equals e to the negative 2x is a solution, and so we'll do that. So I need to have y prime. So I'm going to take the derivative of this thing, which would get me negative 2 e to the negative 2x. So now if I plug y prime into this equation and y into the equation, you can see that negative 2 e to the negative 2x plus 2 e to the negative 2x does equal 0. So yes, then this is a solution to the differential equation. And so then if we were to go through and solve these, solve a differential equation, there is a general form. And again, just like any other time when there is a c involved, our constant that we've been using, then that would be our general solution. And then the final definition that we need to get down is the order of the differential equation is the highest order derivative in the equation. So for example, right here we have y prime equals 4y, and so that would be a first order differential equation. So then we have a couple examples. So we're going to try to verify, we're going to try to show that whether these guys are solutions of this differential equation. So my differential equation is y double prime minus y needs to equal 0. So in order to do that, the first thing I need to do for the first one here, for sine of x, I need to go through and take the derivative of this. So I'm going to go ahead and say, well, y is sine x, then y prime would be cosine x, and y double prime will give me negative sine x. And so now if I plug that in to the equation, I end up finding out that, well, I get negative sine x, there's my y double prime, minus sine x, and that's supposed to equal 0, but it really equals negative 2 sine x equals 0, and that's not going to equal 0. So this is not sine of x is not a solution to this differential equation. Not a solution. All right. And so then we'll try the next one, and we'll say, well, let's see if y equals 4e to the negative x. And if I go ahead, I need to do the second derivative because we're dealing with a second order differential equation. I get negative 4e to the negative x, and then y double prime will give me 4e to the negative x. And so now if I plug this into my equation, I will get, well, let's see, 4e to the negative x minus 4e to the negative x equals 0. Since 0 equals 0, then this is a solution. That's a solution to my equation. And so then we'll try, maybe this is a general solution, so we can go ahead and try this guy and see if it matters whether there's a 4 or not out front. And so I will go ahead and take the derivative of that, of the last one here. And so if I go ahead and take the derivative twice, I get ce to the x and ce to the x. And now if I plug that in, I get, put in my second derivative, ce to the x minus ce to the x equals 0. And so again, we have another solution. So ce to the x is a general solution for this one, just like the other one was a little more particular because we knew what the constant was. So we had two solutions and one that was not. And so then my final example that I'm going to deal with today is basically says for the differential equation x y prime minus 3y equals 0, verify that y equals c to the c times x cubed is a solution, and find the particular solution determined by the initial condition that y is 2 and x is negative 3. So basically they're asking me to go through this and figure out if I plug these guys in to show plug c in for this, that we plug in this y equals c to the x cubed, the derivative and the equation here into this function, do we end up getting 0? That would be the verifying part. Then they want me to go ahead and find out what c is, which gives me a particular solution to this, and that would be what we're looking for. So if I have y equals c to the x cubed, you notice I have a first order differential equation for xy prime minus 3y equals 0. So I can go ahead and take the derivative of what was given to me, which would be 3cx squared. So now I plug this into my differential equation over here, and I have x times 3cx squared minus 3 times cx cubed should equal 0. And if you simplify this, if I multiply my x in here, I'm going to have 3cx cubed minus 3cx cubed, which equals 0. So 0 equals 0. So yes, it is a solution. And therefore, if that's a solution, then I should be able to find the particulars using the given information that y is 2 and x is negative 3. So going back to my original equation, I'm going to say, well, y is 2, and we're trying to find c when x is negative 3. And so when I cube negative 3, c comes out to be negative 27, and then I divide, so negative 2 over 27 is c. So I could have written this will work, this whole process will work without the general equation with the more particular solution, and that more particular solution is y equals negative 2/27 x cubed. And so that's really what we're looking for our particular solution of this one. So this concludes the video notes for 6.1. If you have any questions, please come to class prepared to ask them.